write some numbers down to illustrate what this question is asking. So starting with 201, I'm going to go up to 208. Okay, so 201 is divisible by 1, and actually any number that ends in 1 is going to be divisible by 1, so that's okay. 202 is divisible by 2, and actually any number that ends in 2 will be divisible by 2. But 203 is not divisible by 3 because the digit sum is 5, not rather than a multiple of 3. So that one fails. 204 does work here, but won't always work if it was 214. If I'd started with 211, 212, 213, actually that one would work in that case. Um, then yeah, this one would fail. 205 works, and actually anything that ends in a 5 will always be divisible by 5. 206 isn't gonna, well, it doesn't work here because the digit sum is 8. I could check visibility of 7. I'm not going to do that here because I've already failed some other ones. And 208 in this case is divisible by 8, but it won't, a number that ends in 8 won't necessarily be. Um, Now, one thing to note is that we're not going to have a number that involves 0 at the end because we can't divide by 0. So it's basically got to be numbers from 1 to 8 as the last digit, or we could do 2 to 9. The thing is, we're asked about the sum of the smallest of these 8 integers, and if it works for 2 to 9, then it will also work for 1 to 8, because it's like we said, it's always divisible by 1. So really, this is going to be a focus. So we could do trial and error and try and play around with it, try 211 and so on, but like there's so many possibilities that would have to be pretty lucky to be correct. I'm only expecting one answer. So I want to do a better method than that, and that is to write more generally. And so I'm going to write AB1 and so on, AB2, etc. Well, when I did this question, I actually started looking at divisibility rules. I thought, well, like I said, this is always going to be divisible by 5, this by 2, and this by 1, but the others will have some special cases. For example, it must be that A plus B is a multiple of 3. And there are some conditions for divisibility of 4. It must be the last two digits are divisible by 4, but that gives lots of options. B is equal to 2, 4, 6, or 8. Um, AB will work if it's divisible by 6 if AB is divisible by 3, so that doesn't give us any extra. There is a divisibility rule for 7, actually. Do you know what? I'm going to tell you what it is here. So let's say I've got a number 749. What you do is you take the first two digits and you minus twice the last two digits. And if we do that, I'm going to get, what am I going to get? 56. And then I test to see if that is divisible by 7, and it is in this case because it's 7 times 8, and that is enough to show that 749 is divisible by 7. If you had a really big number, you could just keep doing this process. I could now do 5 minus 12, which gives me minus 7, which is divisible by 7. Um, it's not a great method, but it is kind of a nice thing to add if you're learning divisibility rules, just to be aware of and out of interest. It's generally quicker to divide by 7, but in questions like this or whatever, maybe it could come into could be useful. So we know that AB, and that's AB is digits, not A times B minus 14 is divisible by 7. It's not much use, but it's there. Now, the thing is, with the divisibility rule for 8, it's the last three digits, and that just gives us different combinations of A and B, but quite a lot. Now, I've said all of this, but actually, I don't know, it's not a great method. We don't get, sometimes using divisibility rules is the way to go in math challenge questions. But here, there's such scant information. We're going to have to try different values of B and then find A's to go with it. So basically, when I did it, do you know what? I stumbled across the answer using this method, but I'd made a mistake. So I was just lucky to get away with it. So it's not the way to go. I've talked about it, but I'm going to show you a better way now. And this better way is to realize if AB, I'm going to do a specific example to start with, AB7 is divisible by 7, then so is AB0, because I'm just going back 7 or one step in the 7 times table. We can generalize that. If ABN is divisible by n, then so is AB0. So basically, our AB0 must be divisible by all the numbers from 1 to 8. Oh, I was about to write 9 then. Um, so we need to find the lowest common multiple of 1 to 8, because then we'll find a number, presumably it'll be a 3-digit number, that will be divisible by each of these things. So LCM of this. Right, let me write them as a product of prime factors where needed. I've got 2 squared, I've got 2 times 3, I've got 2 cubed. I just want to say this again, just in case, sorry, if you're happy, then just skip on a bit, but I'm just going to say again, so if AB7 is divisible by 7, we can just do AB7 minus 7 to get AB0, and that will also be divisible by 7. We've generalized it for n, and so if we want AB3 to be divisible by 3, AB5 to be divisible by 5, and so on, then AB0 will also be automatically. And so if we just find a 3-digit number that is divisible by each one of these, 1 to 8, then of course when I find it and I just add 8 on, that number will still be divisible by 8, and so on. That is why we are finding the LCM of 1 to 8. So now I basically take the highest power of each of the prime factors to get the LCM. So the highest power of 2 is 2 cubed. Because if it's got to be in the 8 times table, but it will automatically be in the 2 times table that way. That's why I just have to take the highest power individually. And then for 3, I don't need 9, so I've just got a 3 by itself actually. So this will be divisible by 6 now, and by 3. You can see that. I can actually tick these off as I go. And it'll be divisible by 4. But I've then got to times by 5, so it's divisible by 5 and by 7. Sometimes this gets taught in schools, like when you line them up, or you use a Venn diagram. A Venn diagram here would be like not a good idea, and I don't know. I'm doing. I'm basically. I'm not going to write it all down. Like this is how hopefully you understand how to find the LCM rather than just learning a routine, and you're happy with this. Um, so let's figure it out. I can do this quite quickly by doing 3 times 7 is 21, 2 times 5 is 10, and I'm left with an extra 4. So that's going to give me 84 times 10. It's going to give me 840. Okay, a 3-digit number. So 840 is the smallest number that is divisible by 1, 2, 3, 4, 5, 6, 7, and 8. And therefore, if I add on, 7, for example, it will still be divisible by 7. And so the sum of the digits of the smallest of these 8 integers, well, the smallest is going to actually be 841. So I'll get 8 plus 4 plus 1, which will give 13. And that is the answer. Okay, this is question 24. That little step to realize that isn't easy, but I hope you're happy with it. Just out of interest, let's take a look at 849. Is that divisible by 9? And it's not, because you'd need an extra power of 3 in here. That's why it was not included. So we'd actually have to go to 4-digit integers, I think, to get the similar property for 9 consecutive positive integers dividing into the last digit. All right, well done.